계속해서 두 번째 스페셜 세션입니다. 홍은경 카카오브레인 부사장님께서 강연을 해주실 텐데요. Incorporating AI in Radiology, A New Era of Large-Scale AI라는 주제로 말씀해 주시겠습니다. 환영의 박수로 맞아주시기 바랍니다.
끝까지 오늘 한국말로 할까 영어로 할까 고민을 좀 했는데 영어로 하기로 했는데 네, 그래서 어쨌든 한국말도 잘하니 질문 있거나 궁금하신 점이 있으신 분들은 언제든지 연락을 주시면 좋을 것 같습니다. Hello everyone, my name is Amy Hong. I'm currently a VP of KakaoBrain. I'm mostly working for KakaoBrain healthcare sector because my background lies on the healthcare profession. I'm a radiologist and a medical doctor. So I came up with a very broad topic today, incorporating AI in radiology, a new era of large-scale AI, very ambitious title. So I would like to start today with a brief introduction of what we do here in KakaoBrain, which is one of the most AI-focused tech companies in Korea. And we are also working very hard currently in the field of healthcare. So I would like to kind of introduce you the trials and errors that we're experiencing right now in terms of incorporating large-scale AI in the field of healthcare. So before that, I will start with a brief introduction of what we do here in KakaoBrain. So we are focused on generative AI. So basically, we have all these models that can do language and image generation, and also providing those backbones of large-scale models, we are applying that into the field of healthcare. On top of that, we also have AI cloud platform, where our large-scale models can run smoothly on top of that platform. So first of all, we have CodeGPT. So CodeGPT is a large-scale AI Korean language model that understands the context and solves the problem like a human. So it solves problems with prompt engineering and understanding the concept of the questions and predict conclusions by inferring those sentences. These are some used cases of CodeGPT where it can search for you and it can summarize for you, and it can even create promotional slogan designs or slogans for you, almost creating the equality of like human creativity level. And then we have Carlo, which is an image generation model. So it can actually have text and image as an input, and it will provide various styles of images that Carlo creates itself. And another thing it does is that it can actually recognize human face, and it will implement that on the images that they create in various styles according to the customer's needs. So with all that backbone of large-scale models that I've shown you now, that now we are thinking about what kind of impact that we can make by applying those large-scale models in the field of healthcare. So we have come up with a project within our KakaoBrain healthcare sector called AI CAD, which we believe will have a significant positive impact in people's lives all over the world. So I'm a radiologist, so let's go back to how the diagnostic workflow works. So patients come in to scan for images, and those images can be CTs and MRs, X-rays, as you all know, and the raw data is provided from those scanners. I saw some people from GE today, so I guess if they're here, so GE will be one of the providers to provide those scans. And nowadays, there are many algorithms that reconstruct those raw data to provide images that radiologists like myself can read. So now, after it became the radiological image that I can read, this becomes the area of radiologists. So how does the reading process work like? So when I look at the image, I try to find the lesion. So I try to find an abnormality. When I see an abnormality, I try to characterize that. And also sometimes I need to measure them so that if there is any change from the previous one, or if it has a significantly big lesions that needs to be carefully measured throughout the process. So I'm doing a lot of, in a way, vision tests in my head and combining all those acquired information, I write the final report. So what does that mean is that report is a very complex and comprehensive judgment of all the findings included in the image, and it also has my personal subjective differential diagnosis of this specific image, and it's an end product of my reading process that I can communicate with my patients and fellow clinicians. So, is AI the first ones to help radiologists in making this? No. Computer-aided diagnosis has been in the field for a while. So initially, it was providing us, helping us in very simple tasks, such as finding something, oh, there is a calcification somewhere. But it was very limited in use due to poor performance, and the back then technology was not that great, so it was only limited to certain areas of the radiology that we could implement that on. So around 2016, there was a huge breakthrough while we are here, AI. With that, it has developed tremendously. It was on the speed of development with deep learning together. And now in 2023, we're looking at generative AI, where it can change the whole field of radiology. So how did that advance? So on the left side, you're looking at a nodule that was lesion that was missed by human people, the human radiologists, and AI is creating a heat map for those lesions that were missed by human radiologists. And on the right side, similar pulmonary nodule, but on chest CT, where AI algorithms are actually automatically detecting and measuring the sizes and volumes for that specific nodule. So you can see it was very vision task focused in the beginning of the AI process. So when we go back to what I have to do in the field of radiology, so AI can help me with vision tasks in detecting the lesion, characterizing the lesion, and measuring the lesion. But what about writing reports? As I told you, it is the end product of all of my reading process, and it is my comprehensive judgment to communicate with patients and other clinicians. What about reports? It was still left to me to write all that. So then it comes to the question, what if AI can help radiologists in creating that report? We have language model, we have a vision model. If we combine that together to provide a preliminary report with just an input of medical image that can create preliminary report for doctors and they can confirm. And as though that's how we started our project, AI CAD. So in the field of medical imaging, for the first time, we would like to apply to the interpretation of chest radiographs, which are scanned most often, and for me personally, most difficult because there's so much information, it's actually pretty difficult to read. So with chest X-ray as an input, healthcare professionals can review and confirm the reports automatically generated by KakaoBrain's large-scale multi-model generative AI model. So as there was ADAS before autonomous driving, we expect to open a new horizon in this field of radiology through an efficient and integrated process of generating preliminary reports for healthcare professionals. So technology is advancing, but can we apply that directly to the healthcare? Probably not. Healthcare is a very specific domain because it affects us, our families' lives, and well-being of the society. So we can't just implement all these emerging techniques into the field of medical care. And that's why there are so many regulations controlling and ensuring the safety and the quality of medical care within the society. So from here on, I thought to play with it a little bit and take you, in a way, and invite you to a sneak peek of our journey from a perspective of a radiologist and also a vice president of Ka카오브레인, how we are implementing these large-scale AI models in the field of medical care. So please let me invite you to the sneak peek of our journey and what we're going through in this project. So initially, as I was trying to, when I joined Ka카오브레인, before I actually joined the Ka카오브rein, I had experiences in different medical AI startups. So I knew what, in a sense, I knew what the market was like, and I knew what the models, and I knew what customers wanted. I didn't know everything, but at the same time, I had the sense of it. So when I first joined Ka카오브레in and I was planning this project, my initial concerns were these three. So first of all, clinical applications. So there has been models that are related to X-ray report generation, but at the same time, they were more focused on the technical feasibility of the model and also proving the concept that we can do it. But as a doctor, there was no research done about how that technology can be implemented in routine clinical practice. And that brings to another next question, commercialization. So as I know, we need to get regulatory clearance to actually sell this product. And also we need to consider the reimbursement structure of the different governments and how they're willing to accept that. And also customer expectations. So if customers are paying to use something, they're expecting the quality. So it was a lot of things going on in my head. How can I ensure that? How can I ensure that with our technology? So there was a lot of thoughts in my head, and most importantly, the cost effectiveness. It's getting cheaper, but yet still very expensive, these large-scale AI models. So in a way, we cannot really estimate how much computational costs that we'll need to spend. We're a private company, commercial sector. We need to be able to calculate the return of investment in that sense. So there were initial concerns that I had in my mind, and more fundamentally, data. So I am aware that in machine learning, I'm no expert, but even though it seems like a very similar task to one another, when AI models being asked to solve that same similar question in a different domain, you can't really estimate how much data you will need or how much time it'll consume to do that. So we had no idea how much data we're gonna need. So what did we do? We ran around all over the country to find the data. So our team and myself, we were running around all over Korea for about 6 months. And at the end of last year, we were able to have joint research agreements with 11 different tertiary hospitals around Korea. So here I want to mention why Korea is such a niche for medical AI model development, is that Korea started digitalization of medical records very early in the stage, so the quality is very good. Everything is standardized, and the doctors, like myself in Korea, have very high standard about their medical care in general. So the quality of the data is very good, and we all have great public health insurance in Korea here. So meaning that people have a very high rate of access to hospitals and seeing doctors and examinations, so there's a lot of data. And also, were very prepared to implement these technological developments from the very beginning. So the infrastructure within the Korean society and within the regulation was very friendly for us to actually access the data and also use that to make the backbone of our large-scale AI model. So then, after data was secured, I was able to, in a way, address the more important questions to create the value of this large-scale AI. So there's aspects such as business, research and development, and services, and probably more, but I will only focus on these three for today. So for the business, we had to identify the target. Who's our target? Target customers. Who's our target countries? There are different stakeholders in healthcare sector. So for this project, how do we want to define our target customers? Is it going to be the government? Is it going to be the hospital? Is it going to be the doctors? Or is it going to be the patients? And also we had to consider target countries. Why? Let's say, first of all, they report in different languages. Let's say in Korea, luckily, we report in English. But let's say, I was doing my research fellowship in Netherlands Cancer Institute, and they report in Dutch. Can we use that data to train our model that will provide reports in English? Yes, translational models are pretty good now, but I know it struggles a little bit with medical terminologies, so we need to think about that issue. And also regulations are different according to the countries, not just, let's say, CE or FDA, those regulatory clearance, but also data privacy compliance regulations are also different, so we need to consider that. And most importantly, market size, not only just the population, the reimbursement cost from the government per each medical procedures vary significantly from one country to another, so that was another issue. And infrastructure. So here I say infrastructure, medical infrastructure, because different reimbursement system, different healthcare system provides different infrastructure systems. So let me give you an example. In Korea, we have 건강검진, right? So healthcare checkup. If you are an adult who's an employee, you get everything checked every year. So what happens for us is that there's a lot of normal cases in Korea. But what about US? People don't really get that screening much. So all the cases will be abnormal, and the need from the market will be different. Korean doctors want to rule out normality. So I don't want to see normal, it's just wasting my time, so rule that out for me, AI. But in America, I want AI to detect abnormality and describe it for me, and specifically. So the need from the market is so different. So we had to identify the target countries that we want to target. And the most difficult thing that I encountered was that the users of AI in the field of radiology and the payers of AI in radiology are different. So until now, most of the hospitals pay for AI, but it's at the end, there are doctors who are using the AI. So who do we target? So that was a very different question. So let's see what our users, potential users, doctors think about AI technology. It's actually pretty sad. This was done in 2021 in America. They had a survey to American doctors, American radiologists, and they noted that only 30% of radiologists were using AI in clinical practice, and only 70% of them, so 70% of them had no plans to pay for AI. And 80% of people who were not using AI said, there's no benefit of using AI. So why is that? I need to figure out why my fellow radiologists don't want to use AI. And in a way, it's very interesting because radiologists are at the front line of technology usually. We're the ones who brought in CT. I mean, CT has reached at the level of top of its technological development right now.
MRI, how complicated is that? So we should be tech-savvy people, right, among the doctors? But why are we hesitant to AI? What was the problem? So in my head, I was trying to figure out, we're kind of the late starter in the market. We're coming with a whole new different technology, but at the same time, for the users, we might be another AI competitors, medical AI competitors. So I had to figure out this niche of why the users are not happy with AI right now. And also, previous companies heavily relied on the system to get reimbursement. Since I mentioned before, the payers and the users had a discrepancy between them. So companies had to rely on the reimbursement system of that specific government to sustain their business. But at the same time, reimbursement system differs from one country to another. So that was another difficult issue regarding that. And so even with the AI implementation and the reimbursement, I thought we need to be very creative with how we want to go by in that sense. And what about AI model, the most important thing, right? And we're Kakao we do generative AI. So initially, as I mentioned before, in the healthcare sector, there isn't much room for error. We're not joking around here. We have to be serious. Let's say ChatGPT says something that's not correct. Oh, I'll just laugh and I'll try it again. But let's say my mom went through a scan and AI solution said something completely different. Or let's say it's just something so wrong, then that's not okay. So I'm not saying that any other industry is easier to penetrate, but healthcare and medical system has that specific difficulty to submerge into. So this is in our initial model. So I was very strict with my researchers. We have to be good. There's no mercy for us. Our model has to be good. So initially, our model is trained with both current one single time point chest x-ray and also chest x-rays that had comparison with prior examinations. So on top, you can see in the beginning, it struggled with hallucination a little bit. So the text in blue is showing, so this model was not given prior chest x-ray, but it was saying that I saw something prior, I was comparing something. So there was comparative hallucination. So our team were able to kind of teach them that this, I'm just giving you one single point of images, and there's no prior. And if there was prior, this is how it would look like. So you can see in the bottom, AI-generated output trained with model that understands that temporal difference, has no hallucinations anymore. So that was a good example. So we solved that problem. But now I want to actually open up and ask you guys all these questions. So if you were making these models, let's say automatic preliminary report generation model, how would you assess the quality of its output? So these are reports from one same single image. One is one AI generated and, one is AI generated, and in the bottom, it's the ground truth. So it was written by a human radiologist. So how can we, in my opinion, it has to be, the AI generation model has to be evaluated. Their output has to be evaluated in their reliability, robustness, explainability. Of course, there should be no hallucination. But how can I measure that? Can I just say, oh, it's good, or it's not good? Can there be any, in a way, objective metric to measure that? We're still trying to figure it out. And if any of you have any idea regarding that, please let me know. So it's very difficult. I can't really say which report is better. As I mentioned before, reports are very subjective to a person's judgment. So that's a very difficult question that we go through. And later on, it's the service. how do we deliver this model to our customers? Do we provide API? Do we provide standalone? Or do we provide in the form of platform? And actually delivering these kind of large-scale AI models are very, very difficult. And it's just that a lot of thoughts and resources that we have, how we're gonna be able to allocate them into. And also regulations, quality assurance, regulatory clearance, data compliance issues as the patient data is going through our model to be analyzed. So these were all the concerns that we have, and how do we go by that? We set up hypotheses and test them out continuously in various scales. So let me show you an example. So here is a demonstration webpage where we show our model, and customers can just upload any chest X-rays that they have, and we'll show the output of our AI model in two different versions, full version and simplified summarized version. So why do we do that? First of all, we want to see the feedback from our customers about the quality of this generated report. And second of all, we want to see if they want the simplified form or the full version. So we're testing out through demos. I go out a lot to get feedbacks from our potential customers all the time, Korea, Europe, United States, everywhere I can go. So we're always testing out how we can provide this service, this large-scale model service in the right way to reach our customers. So ultimately, we're taking in all the considerations above and more to identify the niche and creating the value of this large-scale models in the field of healthcare. I apologize, I don't have the answers to all the issues and concerns I raised today, but I thought to give everyone a chance to think about how we can implement that, especially in the healthcare sector, because we have to create the value of this together, I feel like. Personally, I feel very honored to be, in a way, some sort of pioneer in this field, but I do feel very great responsibility on my shoulders to be able to set the tone right. But still, I think I'm very optimistic and passionate about the implementation of large-scale AI in the field of healthcare, and I think it's gonna make a good for our society, but at the same time, it's not a one-man's job. So I hope everyone who are here today can join me in this journey and create a new environment together where this technology makes us, our lives better in a very safe and efficient way. Thank you so much.
감사합니다.